Okay, we're looking at the next section of right triangles. More about right triangles than you ever wanted to know. However, right triangles, because triangles, circles, the most stable geometric forms in the entire universe. So there's an awful lot to know about triangles, particularly right triangles. Used in construction all the time, your ability to use this stuff and understand it, calculate this stuff. If you're doing any kind of design work of anything that uses regular quadrilaterals, squares, rectangles, so forth and so on, your ability to divide things into and create right triangles and determine what those are, and you can design those triangles to be 45, 45, 90 degree triangles or 30, 60, 90 degree triangles, then these relationships and these ratios will help you. When we get into trig, you'll understand more about how these work. And then if you really want to understand these and get into them, then go look at the segment or the clip called Special Right Triangles, the proofs. And we'll get into the proofs of those. You in the honors classes particularly will want to see those because those are the kinds of things you're going to be doing in college algebra, is be able to derive these. By the way, honor students, the ability for you to derive this, that sounds like a really good quiz on this particular thing. So be able to do that, be able to prove and derive that and show that you know how to do that. But we're going to show this. These are two special right triangles, 45, 45, 90. Oh wow, that's an isosceles right triangle, isn't it? Wow, the sides are congruent. All right? And so what I've done in order to help me, and if it helps you, great. If it doesn't, throw it away. Do whatever you need to. What I've done is I set up a little table that helps me understand how to do this. Basically, this 45, 45, 90 is across from one of the 45 degree angles is what we would call an X. Ta-da, there it is. Across from the other 45 degree angle, since it's an isosceles triangle, guess what? Is another X. And if those are X's, across from the 90 degree would be that X multiplied by what? Square root of 2. Well, it makes sense. Hypotenuse is going to be longer than the legs, isn't it? Well, it better not be X. It's going to be longer than the legs by what? Factor of the square root of 2. When we come over to the 30, 60, 90, something similar, except it's a little different. Across from the 30 degree angle, we're going to call that one, if that's X, then across from the 60 degree angle would be X times the square root of 3. In other words, this amount multiplied by the square root of 3 will be this length. And across from the 90 degree angle is just twice it. You take the short side, twice it. How do you twice it? You multiply it by 2. You double it. And that would be the side across from there. So this little segment here is across from the 30. If we call that X, that's just X. Across from the 60 would be this. Across from the 90 would be this. Now, what we're going to do is we're going to do a series very quickly of some samples in this and get these done so you know how to do them. Here is a sample problem. We're given a 45, 45, 90. Oh, that, okay. This is 90. We'll write it in here for a couple of times. 90 degrees. So what we're going to do is we're going to put this over here so you can see it. What's X? Well, those are the legs, right? So that's going to be there, and that's going to be there. Well, what's the hypotenuse? Across from the 90, or Y, would be 8 times the square root of 2. Where did I get that? Well, x times square root of 2. So replace the x with what? 8. 8 times the square root of 2. What is that? I don't know. All I know is y equals 8 times the square root of 2. If I want to find out what that is, I can come over here with my handy calculator and go 8 square root of 2 times, it looks like it is 11.31. Yeah, 11.31. Okay? Could we come back over here and say, oh wow, another way to do that would be 64 plus 64 and take the square root of that. Oh wow, guess what? That equals 11.31. Okay? This is just another way to find the same thing. Okay? Got it? All right, now, let's do another one. You ready? Erase a little chart here. Okay, we got another one set up right here. What is it? Oh, where is it? Let's do it. Oh, this one looks a little weird and different. We're going to come down like this. There's a right angle. This is 45 degrees. This is 45 degrees. And this here, oh wow, 3 times the square root of 2. And now we want to find that one. Well, where is that 3 times the square root of 2? It's across from the what? The 90. So what are we going to put there? 3 times the square root of 2. What do we want to find? We want to find one of the legs. I want to go that way. When we went this way, we multiplied by what was coming over there. How in the world? I got to get rid of that square root of 2. How in the world do I get rid of something I'm multiplying by? I divide by it. When I divide this by the square root of 2, what do I get? Why? 3 square roots of 2 divided by square root of 2. This goes away, equals 3. Okay? Second sample. Pause this if you need to. Look at it. Go through it. See if it makes sense in your head. I'm going on. Next one is, oh wow, we have a square. This side equals that side equals that side equals that side. Oh, this is that, that is that, that is that, that is that. All angles equal, all sides are equal. And we have a diagonal through here. We're told that that diagonal equals 10, and we want to find that side. Well, we have a right triangle here. Oh, wow, it is a 45-45 because that's isosceles. This is 45. This is 45. This is 90. Okay? So, across from the 90-degree angle, across from the 90-degree angle, we're going to put 10. What did we do to get rid of that square root of 2? We divided by it, so what do we got to do with this? I got to do some calculation, sorry. Oh. When I do this calculation, this is going to be 10 divided by the square root of 2. 10 divided by the square root of 2. And when I do that, I come up with 7.07, 7.07. Okay, so take 7.07, 7.07, square it. Take the square root. Oh, guess what you get? You get 10. Not real close to it, 9.998 something. Okay, got it? So 10 is here. That's what you're going to have there. Let's do another one. Okay? These are going pretty quick. Let's do another one. We'll draw another one here. Okay? Oh, we have another square. Okay? We have another square. This one's going this way. There's y is a hypotenuse, and this is 18. Okay? What goes here? The side. So this is going to be 18. This is going to be 18. And this here will be 18 square roots of 2. What's 18 square roots of 2? Times the square root of 2 equals 25.46, I believe. Okay, so if we take 18 squared, golly, if we take this and we square it, and we take this and we square it, and we put those back into our Pythagorean theorem, guess what we're going to get for the answer for our hypotenuse? Got it? All right, we're going to leave that, and we're going to go over here, okay? And we're going to try some of these over here on this side with this one. You ready? Okay. And we're going to do the very same sort of thing. I've got one over here. It looks like this. Make these a little bigger. This is 30 degrees. This is 60 degrees. And there's your 90. What do we got over here? We got 1/2 we got Y and Z. So, across from the 30-degree angle, is 1/2. Well, I'm going to get this one real quick. What's my Y going to equal? My Y is going to equal, it's across from the 90, and it's 2 times that. That's just 1, isn't it? So that equals 1. What's this going to be? I'm going to take what this is X. I'm going to take 1/2 times the square root of 3. Okay? Alright, so I'm going to take the square root of 3, divide it by 2, 0.866 is what that equals. Okay? Understand? This right here, across from the 30-degree angle is X. Whoops, put 1/2. Put 0.5. Oh, across from the 90, I take what's in here and I multiply it by 2. Okay? I take what's in here, multiply it by square root of 3 to get this one, and that's what you get. Alright, look at it, stop this, do what you need to. Going on. Let's do the next one. Got 3 or 4 of these. Next one is, oh, these get complicated. I don't know why the samples get complicated. This is 30. This is 60. Oops, there's my 90. Now, we're going to call this Y, Z, and this is 9 times the square root of 3. That's across from my 60-degree angle. So I'm going to put 9 times the square root of 3 right there. What do I got to do to get it over here? I got to get rid of that square root of 3. How do I get rid of that square root of 3? Well, 9 times the square root of 3 divided by the square root of 3, what goes away? Guess what this is? Oh, guess what this is over here? Twice at that. I twice it. I twice it. Twice it is 18. Now I'm doing these pretty quick. It's on video, people. Stop it. Look at it. See what you come up with. Okay? All we're doing is following this. Follow what's given. What are we given? We're given the thing across from the 60, so I stick it there. I got to get that down to X. How do I get that down to X? I got to get rid of that square root of 3. I divide by, oh, I get a 9. How do I get this one? I take what's in this column and multiply it by 2. Let's do another one. Okay. Oh, this one's turned around a little bit. Looks a little bit different. This is 30. This is 60. Here's my right angle. This is 8. This is Y. This is Z. Okay? So across from the 30-degree angle, is 8. Well, what's this one going to be? Well, it's going to be 8 times the square root of 3. What's this one going to be? It's going to be 2 times 8. So this is 8. And this one over here is 16. I can do that one in my head. Square root of 3 times 8. Is 13.86. 13.86. Okay? Pretty simple. Cross. What do I do with it to get there? Square root of 3. What do I do with it to get there? Multiply it times 2. Okay? And one last one we're going to do. This one's a little different. But let's see what happens to it. Okay? We're going to do this one this way. We have an equilateral triangle, we think. I don't know. This is 60 degrees. And we got this going here. I want this and this. And this is 20. And I know that this equals this. Well, if this is 60 degrees, I know this is 60 degrees. If those two are 60, let me see, 180 minus 120 is 60. So I know that this whole angle is 60 degrees. Oh, guess what? This right here is 30 degrees, and this is 30 degrees. Okay? So I have a 30, 60, 90 degree triangle. It's a special right triangle, 30, 60, 90 degree triangle. I cut an equilateral triangle in half by dropping an altitude from any vertex. I got a 30, 60, 90 degree triangle. I got two 30, 60, 90 degree triangles. In fact, that's how we prove this relationship. Go look at special right triangles, the proofs. Where is this thing? Oh, it's the hypotenuse, isn't it? It's across from the 90 degree angle, so I'm putting 20 right here. Now, how do I get this 20 over here? What do I do to this 20 to make it x? Well, I take 20 equals 2x divided by 2, x equals 10. What do I do to here? 10 times the square root of 3. What's 10 times the square root of 3? 17.32. Let's try that again. Yep. 17.32. So, what's my z? My z is 10. My y is 17.32. Okay? Special right triangles. All done.